Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. Imagine this. A student loses 2 marks on a past paper because they sketched y equals x minus 2 squared as if the vertex were at 2, 0, but plotted it at minus 2, 0. Simple sign mix-ups like that cost easy marks. Today I'll give you the exact thinking that makes those mistakes disappear.
Promise. In the next 10 minutes we'll cover 3 things. First, the core concept, how translations, stretches and reflections each change a graph. Second, a step-by-step worked quadratic example you can copy in the exam. And third, a 30-second plug-in check and a mnemonic so you don't reverse the order of transformations. Sound good? Let's work through this step by step.
Section 1. The concept. Start simple. When we write y equals f of x and then y equals f of x minus 2, what happened? The graph has moved 2 units to the right. It feels backwards at first because the algebra is inside the function, but think of x being replaced by x minus 2, so every x value that used to work now needs to be 2 bigger to give the same input. For y equals f of x plus 3, the graph shifts 3 units left. Vertical translations are straightforward. Y equals f of x plus 2 lifts the whole graph up by 2. Y equals f of x minus 1 moves it down by 1. These affect y values directly. Think add to y, move up.
Now, scale factors. If you see y equals 2 f of x, every y value doubles. Peaks get steeper, zeros stay where they were, unless the factor affects x. For a horizontal stretch or compression, you alter x. Y equals f of 2x compresses the graph horizontally by factor half because you need smaller x to reach the same input, while y equals f of x over 3 stretches it by 3. Write these as mappings if it helps. Take a known point and show where it moves. Reflections are the final basic move. Y equals minus f of x reflects the graph in the x-axis. Positive y becomes negative and vice versa. Y equals f of minus x reflects in the y-axis. The shape flips left to right. Keep the axis in mind when sketching intercepts and key points. A quick linear example. Start with y equals x. If I do y equals minus 2x minus 3 plus 1, break it down. Inside the bracket, x minus 3 shifts right 3. The minus 2 reflects and stretches by factor 2. And plus 1 lifts it up by 1. Mapping the origin is a fast check. Origin 0, 0 goes to 3, 0 after the shift, then stretched and reflected gives 3, 0, still 0, then plus 1 gives 3, 1. That point tells you where the line passes and helps sketch accurately. For quadratics, focus on the vertex and intercepts. Start with y equals x squared. For y equals x minus 2 all squared plus 3, the vertex moves from 0, 0 to 2, 3. If there is a coefficient, like y equals minus 2 x minus 2 all squared plus 3, that minus 2 flips the parabola upside down and makes it narrower. Always list a few transformed key points, say the vertex and 2 symmetric points either side, and connect them smoothly. The examiner wants labelled key features, not a guessy curve. Section 2. Worked example plus exam technique. Let's work through a compound transformation and show the method you should write in the exam. Question. Sketch y equals minus 1.5 in brackets x plus 2, close brackets, squared plus 4, starting from y equals x squared. First, note the basic steps out loud so the examiner can follow your thinking. Mapping, algebra, substitution, and labeling. Write it down. The examiner wants to see your method.
Step 1. Identify transformations in order for interpretation. Inside x plus 2 means shift left 2. The minus 1.5 outside is a reflection in the x-axis and a vertical stretch by 1.5. The plus 4 moves the graph up 4. A useful sentence to write. Start with y equals x squared, shift left 2, reflect and stretch by 1.5, then translate up 4. That single line already earns credit for method because it shows correct setup.
Step 2. Transform the vertex. The base vertex is 0, 0. Shift left 2 gives minus 2, 0. Apply minus 1.5. Y remains 0 because 0 times anything is 0. Then add 4 gives vertex at minus 2, 4. Write that as a labelled point on your sketch. That's crucial.
Step 3. Pick a simple point to map, for example 1, 1 from y equals x squared. Show mapping explicitly. Original point, 1, 1, maps after shift left 2 to minus 1, 1. Apply vertical stretch and reflection, y becomes minus 1.5 times 1 equals minus 1.5. Then add 4 gives y equals 2.5. So 1, 1 maps to minus 1, 2.5. Write down the calculation in the script of your answer, M1 for the method of mapping, M1 for correct transformed coordinates, and A1 for labelling the final sketch clearly. The examiner can award marks even if your sketch is a bit rough, as long as your working and labels are clear.
Common pitfall. Students apply the plus 4 before the stretch, or forget that reflection multiplies the y value. Always apply inside changes to x first, then scale or reflect y values, then final vertical shifts. Write the mapping like x, y to x minus 2, minus 1.5y plus 4 for one mapped point, and show the arithmetic. Write it down, don't just think it.
Section 3. The quick win and common mistakes. Quick win. The 30-second plug-in check. After you sketch, pick 1 or 2 original points from the parent graph, the vertex and one more, and substitute the x into the transformed equation to check the y you sketched. If your plotted point doesn't match the substitution, correct it. This takes 30 seconds and catches most careless errors.
Mnemonic for order. Inside first, then stretch and flip, then move. Say it once before you start sketching. So pass operations as horizontal shifts, inside, then scaling reflection, then vertical shifts, outside. That simple rule prevents the classic reversed order errors under time pressure.
Extra. Common mistakes summarized with quick fixes. Mistake 1. Forgetting to label the vertex. Fix. Write coordinates in brackets next to the point. Mistake 2. Not showing a mapped point. Fix. Show one example mapping with arithmetic. Mistake 3. Drawing an unlabeled, unscaled curve. Fix. Mark intercepts and one extra point. For parents and teachers, use the printable checklist on the website to make quick quizzes. 3 small questions per week builds fluency faster than one long session.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and a printable checklist at jcacademyonline.co.uk. Visit the site for step-by-step worked examples that mirror what we do on the show. Trust the process and nail that exam.
Recap in one sentence. Treat transformations in the order inside, scale/reflect, then outside. And always show a mapped point and label the vertex. Marks are there for the taking. That's your quick win for today. Stay curious. Until next time, read the question twice. Solve it once.